Hi, everybody. Welcome to today's webinar. We'll get started in just a minute. Okay, it looks like we have most everybody in from the waiting room. So thank you so much for joining us today, and welcome to the Wisconsin chapter of the Wildlife Society's Brown Bag webinar series. My name is Allie Scott, and I'm facilitating today's webinar. And so before we get started, I'd like to talk just a little bit about the Wisconsin chapter of the Wildlife Society. So for those of you who don't know, the Wildlife Society is an international professional organization for students and professionals in the field of wildlife, natural resources, and conservation. And so we have a state chapter here. This is the Wisconsin chapter, and several of the universities also have student chapters. And so anyone can become a member of the Wisconsin chapter. So if you're not already a member, you're welcome to join. There's a lot of really great benefits to being a member, such as attending our annual conference, which is a great way to network and to learn about a lot of different research and management efforts going on in the state. And the chapter also hosts a variety of professional development and training opportunities and offers scholarships. And members can also be involved in several different committees about a variety of topics like fur bearer management or diversity, equity, inclusion in the wildlife profession. So there's some really great resources and ways to get involved where you can make a difference. And so if you're already a member of the Wisconsin chapter, but you know somebody who isn't, you can give them a free one-year membership. And so this is called the Give Back program, and it was launched last summer. I will put a link to the program in the chat, and I would encourage you to think of someone you'd like to nominate for a free membership, because I bet a lot of us can think of somebody who could benefit from that. And so finally, the Brown Bag webinar series has been really successful so far. We've heard from a lot of great speakers on a variety of topics, but we're in need of more speakers for future webinars. So if you or someone you know is interested in being a webinar speaker, please get in touch with us because we would love to hear from you. And so with that, let's move into our topic and our speakers for today. So the title of today's webinar is Making Better Decisions, Decision Science Approaches for Informing Natural Resources Management. And we're lucky to have two speakers here to present on this topic. So Jennifer Price-Tack and Christine Anhalt-Depies are both here. So Jennifer Price-Tack is a large carnivore and elk research scientist at the Wisconsin DNR in the Office of Applied Science. She has a PhD in wildlife sciences from Auburn University, a Master of Environmental Sciences and Management from the University of California, Santa Barbara, and a bachelor's in zoology also from the University of Santa Barbara. She completed a postdoc position at Cornell University before joining the DNR in November 2019. Jennifer has expertise in population modeling and decision analytics. Her research focuses on applied science for informing management decisions of wolves, bears, and elk in Wisconsin. And additionally, she lends her expertise in decision analytics to a variety of natural resources problems within the agency. So welcome, Jennifer. And Christine Anhalt-Depies is the past president of the Wisconsin chapter of the Wildlife Society. She's also a research scientist at the Wisconsin Department of Natural Resources, Office of Applied Science, where she coordinates the Snapshot Wisconsin project. Christine has a PhD in the Human Dimensions of Wildlife from the University of Wisconsin-Madison. She has a Master of Conservation Biology and Sustainable Development, also from UW, and a Bachelor's in Biology and Psychology from Ripon College. And Christine has expertise in engaging the public in natural resource science and management, and her research uses social science data collection and analysis methodologies to answer applied questions. She also supports decision science efforts in the agency as an assistant decision analyst. So welcome, Christine. Welcome, Jennifer. We're excited to have you both here, and I will turn things over to you.
Great. Thanks for that introduction, Allie. First, let me double check. Can you see my full slide?
Yes, you're good to go.
All right, great. Let me just get situated. All right. Well, first, thanks for allowing Christine and me the opportunity to talk about decision science and natural resource management. It's certainly something that we're both passionate about, and I classify myself as a formerly indecisive ecologist, and that decisions are hard, and uncertainty, risk, all these things, conflicting objectives can make it really hard to make decisions and not fall into that decision paralysis state. So Structured decision-making, decision science is something that I came upon during my graduate work, and it really resonated because it provides this really common sense framework for making better decisions that I use in my personal life as well as my professional life working with the DNR. So today we'll give some background about decision science first, and then jump into some example projects from our own work, including 2 from here in Wisconsin. We've tried to select a variety of projects to give you a sense of the diversity of challenges and also the tools that decision science can provide to support robust and transparent decision-making. In those examples, we will be glazing over many details just given time, but we'll be happy to go back and discuss details further if there are questions after our presentation. All right, so today we face a lot of decisions that are nothing like the decisions that our brains have actually evolved to tackle. And this is absolutely the case in natural resource decision-making, where we're dealing with these big, complex decisions, stakeholders, conflicting interests, and typically loads of uncertainty. Now, research shows that our human brains aren't that great at tackling these types of decisions. And then it turns out we're more likely that rather than think carefully through a decision, we're naturally more likely to make it and then develop a narrative around why we made that decision. So, I mean, that's not ideal and can lead to some outcomes we could have avoided. However, honestly, that type of decision-making, that kind of natural gut instinct decision-making is fine for most decisions. Here's a graphic by Ralph Keeney. He's a heavy hitter in the decision science world, and he classified how 10,000 everyday decisions are resolved. Most of them are no-brainers, or they have such little consequences that they don't require a lot of consideration. But then there are about 10% that are worthy of critical thought. And of that 1,000, Keeney says that we only give systematic thought to about 40 of those, when we should really be applying structured thought to all 1,000. So natural resource management problems, as you can imagine, are largely within this 12% or this 10% of problems requiring systematic thoughts. And that's because we're rarely dealing with no-brainers decisions or low-risk problems. I think it's also important to note that a trained decision analyst like Christine or me isn't needed for all of these 1,000 problems. Many can be resolved just with clear thinking. However, there are some that are going to require more complex approaches, including quantitative models for evaluating the various options. So what is structured decision-making? Structured decision-making is a framework to help us clearly think through a problem. And I like how Keeney himself describes it. It's a formalization of common sense for decision problems which are too complex for informal use of common sense. In other words, most problems, issues, challenges, and controversies can and should be reframed as decisions. Decisions are the only way to affect change in our personal lives, in our professional lives. Even doing nothing is a decision that can lead to some big ramifications. So SDM and decision science more broadly draws on many different scientific fields, including economics, psychology, and computer science. It provides this framework to transparently deconstruct, analyze, and synthesize a problem in a way that makes efficient use of science while also explicitly accounting for values. And there's a huge history in this. I've highlighted a couple books here, specifically in natural resource management, this one here, these 2. And then this is another one, this book, Smart Choices, is $10 by Ralph Keeney and his co-authors here. And I would highly recommend it. For $10, you're going to make much better decisions for the rest of your life. So what makes SDM different than the more familiar approaches to decision making? Well, those familiar approaches tend to oversimplify decisions because, again, our brains just can't handle too much complexity, and they ignore inherent subjectivity. A big misnomer that I hear a lot is this term science-based decision-making. Now, while science is critical to decision-making, and it's what I do, it is ultimately values that drive a decision. And I think a good example is Google Maps, which is this incredible tool for helping us get places as quickly as possible. If there's an impressive amount of science behind it. It considers traffic, our route of travel, if we need to stop somewhere in between. But The limitation of Google Maps and of science is that it can't tell us where we actually want to go. In order for Google Maps to tell us the best way to get there, we need to know where there is. So SDM provides a roadmap for decision-making that'll help us figure out where we want to go, and then also the best way to get there. It offers a range of tools for each step in this process. And so I'll walk through it first. Everything starts with a trigger, and that's some circumstance that initiates the need to take an action or consider taking an action. Once you identify that you need to make a decision, you define your problem, and that includes defining your temporal and spatial scale of this problem, identifying decision makers, who the decision affects, who should be involved in the process, and what resources are available for this decision. Next, you want to outline the objectives, and this is the most critical step, where we're explicitly discussing and defining the values that are driving the decision. It's often skipped, or we don't dig very deeply into underlying values driving the decision. We also work to define metrics for each objective, and that's metrics that can be used specifically to compare how well alternatives are expected to meet defined objectives if implemented. Once we have the objectives defined, we move on to identifying a suite of alternatives that can be implemented. Now, SDM motivates a lot of creativity to overcome natural tendencies to anchor on the status quo or a person's preferred alternative. And for anybody who's been involved in natural resource decision-making in large groups, stakeholders usually come into a room with the alternative they want implemented already on their minds. And so what this process does is helps the group take a step back, identify objectives, and then find alternatives that may achieve a better balance across the conflicting objectives. Next, we move on to consequences. This is where we're predicting the consequences of each alternative on each one of those objectives. One great tool that we use that's really simple and transparent is called a consequences table, where up here we would define the problem, including the scale of the problem. And then we list the objectives and the relevant metrics for this problem. In the next columns, we have our alternatives. And within each one of these cells, we are predicting how well each of these management alternatives will affect each objective, specifically using that defined metric. And those metrics can be quantitative or qualitative. So these could be values, or they could be pluses and minuses, or good or bad, anything like that. So there's a ton of flexibility here, and a ton of adaptability. So once we have the consequences, we can evaluate the trade-offs. There are often competing objectives to consider, especially in our field. And SDM provides a wide range of tools that explicitly consider those trade-offs. So this is where we consider how risk and uncertainty affect the decision. And sometimes we may want to hedge our bets if we want to avoid a particularly poor outcome. Finally, information is provided back to the decision maker. And critical to note here is that SDM does not make a decision for you. It's a decision aiding tool, and ultimately it is up to the decision maker to use that information as they see fit and ultimately to take action. So importantly here, there are very clear roles for science versus stakeholder input and public values. This is all policy and values over here, and science comes in and helps with the prediction part of it to find the best alternative that will balance across all the objectives. So I'm going to pass it on to Christine to talk a little bit about how stakeholders fit into the decision-making process.
Thanks so much, Jen. Folks in this room probably already know that there's many good reasons to engage the public in decision making, and this is more generally, not just limited to structured decision making. And broadly speaking, I would say that there's two philosophies around why the public should be engaged in decision making. And the first is more of a normative philosophy around democratic legitimacy. This is the idea that all those who are influenced by a management decision should be given the opportunity to actively participate in that decision-making process. And this can lead to benefits like increased public trust, empowerment of stakeholders, increased likelihood that the decision is perceived to be fair, and also an opportunity to promote social learnings, to learn from one another during these decision-making processes. The second philosophy around why we should engage the public in decision-making is more pragmatic in nature. This is the idea that complex issues and management really can't be tackled without taking into account a stakeholder's information or perspectives. And so in this way, engaging the public leads to higher quality of information and a variety of ideas that are available for decision making. And engaging the public can also lead to an increased sense of ownership of the decision, as well as increased adoption of the decision and compliance with that decision. Next slide, please. But the reality, of course, of engaging the public in decision making is that it's pretty difficult. The quality of the decision might improve through participatory decision making, but that's really entirely dependent on the quality of the process that leads to that decision. So a garbage process, we're probably going to get garbage out, but if we have a good process, we are more likely to get a good decision out. Next slide. So what does a good process look like? There's a robust literature on what makes for a good participatory process, and I've listed some of those characteristics of a good process here. It's things like participants must have the power to really influence the decision. They need to be considered early in the process. Relevant stakeholders should be represented systematically. And you also might note that a few of these last ones listed on here are SDM inherently does some of these things. So it establishes clear objectives for the process at the outset. Rather than seeking consensus, SDM recognizes that trade-offs are inherent in decision making, and it also provides this really clear space for scientific knowledge to be integrated. So in my opinion, SDM provides this really strong foundation for a high quality participatory process. So from where I sit, there's many benefits to SDM compared to more traditional decision-making approaches. It's deliberative, thorough, uses values, but also integrates science and is robust to uncertainty, making it more likely to achieve the objectives of the decision maker. At the same time, it also considers competing values, which of course we often have in the cases of natural resource management. It's transparent. So as you saw in a previous slide, Jen talked about the consequences table where we can clearly document our objectives and our actions and what were considered and why a particular action or choice was made. And so all of these elements make structured decision making more likely to be supported or accepted by others. However, there are limitations to structured decision making. It's certainly not a panacea. We know that we need to have the decision maker on board with the process in order to use structured decision making. This can be challenging. We can't always assume that this is the case. Sometimes there are also multiple decision makers, or a decision maker will be unclear, or it's unclear who is the decision maker. We also know that SDM is not appropriate for all problems. And so here I'm talking about the graphic that you're seeing on the right-hand side of the screen. Structured decision making is best used when the objectives are relatively clear and the science is not disputed. If you have cases where stakeholders don't acknowledge the validity of other stakeholders' values, then SDM is not the right framework, and something like conflict resolution is probably more appropriate. Likewise, when the science is disputed, there's a separate set of tools and approaches that can be used in decision making, such as joint fact finding. I also wanted to point out in this figure, sorry if you don't mind going back just one slide, where adaptive management is. This is a term that many of you are probably already familiar with, but you might not be aware that adaptive management is actually a special case of structured decision making used when there's uncertainty in the science. So in the next slide, we would argue that adaptive management is often misapplied and framed incorrectly as trial and error management. But instead, adaptive management really is a special case of SDM that tackles structural uncertainties using monitoring to evaluate alternative hypotheses about how a system works. And the idea then is that updates to knowledge can be made over time to reduce that uncertainty and then adapt the management decision accordingly. The graphic that's on the screen here is a well-known example applying adaptive management to mallard harvest, where there was uncertainty in the system. The Fish and Wildlife Service developed these 4 different models representing different ideas about how the system really operates. There's uncertainty whether harvest was additive or compensatory, and also some uncertainty about whether recruitment was strongly or weakly density dependent. So the 4 lines that you're seeing on the screen here are alternative competing hypotheses. And these were, when there was little information about the system, which model was correct, these were weighted equally. So you can see this in 1995, where all the models were weighted equally. But then as more information became available, the weights of the models were adjusted. And so 2 of the models towards the top there were given more weight than other models where we found that the science, or where Fish and Wildlife Service found that the science wasn't supporting those hypotheses. And so the weights of the models can be updated based on what are best supported by the science. And uncertainty affecting the decision can be reduced over time. So for the rest of the presentation, you're going to be hearing, as Jen said, several case studies in structured decision making where either Jen and myself played a role as a decision analyst. And a decision analyst is someone who helps the group apply the structured decision making framework. You can think of a decision analyst as a facilitator for structured decision making. They do things like lead expert elicitation workshops, develop decision tools, and assist with the co-production of science. Ultimately, the role of structured decision-making and a decision analyst is to assist with bridging the gap between science and policy decisions, which, as you all know, can be notoriously difficult. So now I'll pass it back to Jen to walk us through some case studies.
Thanks, Christine. All right, so we'll dig in here again. We'll be glazing over a lot of the details here just to give you a better idea of the breadth of decisions that can be tackled using structured decision-making approaches. So I'll start with elk in Wisconsin. I started my position in November of 2019 with the DNR. And since then, I've served in a scientific advisory role on the Wisconsin Elk Advisory Committee. In this role, I provide information on the elk population to inform decision-making. And as part of that, I've been informally applying SDM principles. And specifically, this has been an informal application of SDM. I don't even use the term during discussions because it's so commonplace. It makes sense for these type of decision-making conversations. So during the first meeting I attended, I worked with the committee to flesh out their objectives. The main decision that they were making annually is concerning harvest. And this led to some really important discussions about how harvest affects the objective, specifically by influencing the bull age distribution. And those conversations highlighted a research need and also provided insights that were directly integrated into the draft elk management plan. The committee members discussed their objectives, including metrics needed to evaluate how well various management options, so harvest quotas, will get us where we want to be. And again, this is analogous to setting the intended destination in Google Maps. So here are the objectives. I'm not going to go into them in lots of detail, but overall maximizing herd growth. And we'll specifically be talking about the northern elk herd today. And so a relevant metric is the growth rate of the total population. Also, The next objective, maximizing hunter satisfaction. And the committee decided that there were two major components here: opportunity in the total number of tags available, and then also availability of mature bulls for harvest. Next, maximizing value of elk for wildlife viewing, so providing a wow factor of having mature bulls available for viewing. Maintaining desired sex ratios for ecological purposes, and then maintaining desired age structure of both bulls and cows. And then finally, minimizing negative impacts of elk. And so these are objectives relevant to elk management broadly, but some of them may not be as relevant for harvest discussions. And so we'll be focusing in on ones related to harvest satisfaction and bull age distribution and desired sex ratios. There were several harvest alternatives discussed during these meetings, including bull quotas, cow quotas, whether there should be an archery only season, and which parts of the northern elk range should be open to harvest. The committee decided fairly easily to not evaluate options using archery only or cow harvest, but did decide to open up the Flambeau portion of the northern elk range to harvest, where in previous years only the Clam Lake portion was open. So this leaves us with alternatives related to the bull elk quota. Prior to the meeting, I had developed a new stochastic dynamic population matrix model, a lot of words, to take the elk herd data and simulate how various quotas would affect the population and the herd metrics that the committee cared about. The model was based on previous work by Lane Stowell and Dan Storm of the DNR, but this model projects population out further than a year using the current year's population as a starting point. And this is a conceptual model of that population, where each circle represents a different age sex class of elk, and then arrows represent how an individual can transition from one stage to another. So aging into older age classes or remaining within an age class. And then the curved arrows on top represent calf production. So at this point, we had more detailed information on cows, but not for bulls. So we did not have any information to evaluate how harvest regimes would affect the bull age distribution. And when we looked back at the objectives of the committee, this bull age distribution was clearly identified as an important metric for several of the objectives highlighted in blue. But the committee still had to make a recommendation for the quota that day, deciding to keep the quota as the same as the previous years, to be conservative. But between that meeting and the next annual meeting, I revamped the population projection tool to better inform their discussion for subsequent quota discussions. So here's the conceptual model of those changes, and also a few model details for the nerdy modelers out there. I collapsed the cow ages into one adult cow stage because as monitoring has become less intensive for the elk herd, we have less information on age of cows. I also split bulls into the 3 age categories you can see here: spikes, 1-year-olds, which are 1 year old, raghorns, 2-year-olds, and then mature bulls, 3.5 years and older. This is a 2-season, 2-sex population matrix model with a pre and post calving season. And it incorporates expected variation in those parameter values in survival and reproduction, producing confidence intervals around the median estimates, which gives us a more realistic picture of how the population may respond over time, including best and worst case scenarios, such as if several severe winters in a row reduce survival and how that would affect the total population trajectory. We then parameterize the data requiring survival and calving rates. We make some assumptions, including about the age distribution of the bull harvest and the harvest success ratio, or the harvest success rate, and then we press go on that model to run the various simulations. Working with the committee, they were interested in not only determining the quota for a given year, but they also wanted information on when that quota might be increased based on the starting quota. So the desire was to be conservative with the quota and risk averse to a situation where an aggressive harvest in 1 year may result in the need to reduce the quota in the next year. So in other words, the committee was interested in long-term impacts of harvest, not just the short term. So in addition to building the tool to evaluate constant quotas over the 5-year time horizon, the committee also developed quota projection rules to determine whether the quota could be increased in subsequent years. So I won't go into too much detail, but basically that the population needs to be increasing over the previous 2 years. It set a floor for the total number of bulls for the population, also a floor for the bull to cow ratio. And so for here, it had to be greater than 40 bulls per 100 cows. And then finally, a floor for the total number of mature bulls, again, being available for things like recreational viewing and for opportunity to harvest. So I then integrated these rules into the decision tool, and the output of that tool produces a report like this one on the right. So there's a lot of output from the tool. We have population, size of the herd over time, projected total bull population under each harvest scenario. And then, hold on. Yeah, and then also this summary table. I'm not going to go through all the different plots that we have from the report, but I'll focus here on what is ultimately a consequences table. This table has the harvest quota scenarios on the left. Some of these where you hold the quota constant, and some of them where you use those population rules to determine whether or not you can increase population over time. And then we have the metrics that the committee cares about. We have bull to cow ratios, mature bull to cow ratios, total bulls, mature bulls, total population, and percent growth over the time horizon. I'm not going to go into all these details, but it definitely highlights the trade-off of providing the maximum number of tags for hunting opportunity and also for protecting that bull age or the mature bulls that are important for several of those objectives. Also notice that with each of these quota alternatives, we have our confidence intervals here. So we have a better understanding of the uncertainty that's inherent in these systems. All right, so I'll transition next to a project I got inspired to take on during my dissertation after some conversations with biologists in the Alabama Department of Conservation and Natural Resources. So arguably one of the most important concerns related to declines in hunters, at least from a state agency perspective, is that hunters bear a large weight of funding conservation for both game and non-game species. Yeah, I've seen a paper where 65% of state agency funding across the state comes from hunters and anglers. In some states, that's over 90%. Money comes in directly through state license sales, but also indirectly through equipment sales, such as through Pittman-Robertson funds. Now, there are a lot of people concerned about what this means for state agency conservation funding. There have been many great minds exploring this issue, estimating population dynamics like recruitment, retention, and simulating simulating hunting populations given current trends and are altering some of those vital rates. And through these studies and others, we've identified a lot of leverage points, so population vital rates that can have the greatest impact on hunter populations. So namely recruitment of youth and women, and also retention and reactivation. Now we want to take this information and apply it within a decision-making framework for state agencies. With the specific questions, can agencies use this information to influence the population? And will action be enough to sustain funding for conservation? Working with Alabama's state agency, we developed a framework to help inform decision-making with regards to hunter populations. So this is similar to elk harvest conceptually with some tweaks. So we developed a modeling tool to evaluate management actions that aimed at increasing hunter populations, and then demonstrated the utility of such a tool, a decision tool within structured decision-making framework, specifically highlighting how it can inform agency decision-making and help better anticipate the future of those hunter-generated conservation funds. So here's a problem. How do we manage hunters to increase recruitment and state license sale profit, with the objectives of maximizing the annual license sales and minimizing costs of management? And the alternatives we looked at were outreach programs, so specifically youth outreach alternatives and adult outreach alternatives. So here I'll list them. Do nothing, which should always be considered in the suite of alternatives because it is a valid decision. Outreach for youth, and we estimated that at $75 per youth participant. So these are different levels of youth outreach. And then outreach for adults, similar. And then finally, a combination where we combine adult and youth outreach. We build our conceptual model based on the Alabama system and their hunting regulations, where you have a youth population. So these are individuals under the age of 16 that don't need to purchase a license to hunt. There are also potential license holders who are older than 16 who do not hold a license in a current year, annual hunters, and lifetime hunters. And just as with the elk model, each arrow is a population vital rate. For example, what is the rate at which a potential hunter remains a potential hunter versus purchases a license and transitions into the annual license holder category. So to demonstrate the utility of using SDM in this population and this decision tool, we use the model to simulate the impacts of those outreach programs on license sales and license sale profit. And here you can see how it works with the conceptual model, where you have youth outreach increasing the likelihood that a youth individual is going to transition and buy an annual license, and adult outreach is going to increase the likelihood they purchase a license and that they remain within the annual license holder class. So the results show that the cost of the outreach programs, especially for youth individuals, may not achieve desired increases in conservation funds. There are a bunch of reasons for this. One of them is there's this lag time between when a youth individual may participate as an 8-year-old and then turn 16 and actually purchase that license. And also some questions about, are also data that suggests that most youth participants, at least during this time, were already likely to become hunters because their parents hunted. So I also conducted, so here's the net present value. So this is the profit of license sales, and then these are the various scenarios. So each bar here, where we have do nothing, and then any of the youth only outreach programs resulting in less profit relative to do nothing. I also conducted a sensitivity analysis varying costs of outreach and transition rates of outreach participants into the license holder stage. And these sensitivity analyses are great because often we can be hampered by uncertainty and feel like, oh, we don't have enough information to make the decision. We need to collect more data. A sensitivity analysis is a gut check on that, or a quantitative check on it, and that we can vary those parameters together and then see, does that uncertainty actually affect the decision? And in this case, with our sensitivity analyses showed that across recruitment rates for adult outreach participants and across the cost expected for those outreach participants, we really didn't see a whole lot of change in what the recommended strategies should be. In every situation, it's either do nothing or adult outreach at 5%, showing again that youth outreach just wasn't feasible in this case. And then moving on, I'll go through really quickly some of the work in my postdoc. And the problem I worked on here was how can managers of allocate their budget across invasive species, areas, and actions to achieve their objectives. This was a very big problem. I worked with the 8 different regional partnerships for invasive species management, worked with the New York State Agency. We were considering hundreds of species, I think 280 species across the entire state. And these are very diverse species. We have aquatic, we have fish, we have like aquatic and terrestrial organisms, we have, insects, etc. And in particular, invasive species decisions have to be made with little data and just absolutely loads of uncertainty. That's uncertainty in species characteristics and their impacts. Uncertainty in spatial heterogeneity. The assets that we want to protect from invasion are not uniform across the landscape. Also, species distributions, we're typically lacking information on presence and absence data of species, and then treatment effectiveness as well. What's going to work? This project was also a good example of how we can harness expert knowledge to parameterize models when scientific studies aren't available. And in particular, this picture is from an expert elicitation workshop where we got information, we leveraged expert knowledge in order to parameterize a model. Specifically, for example, we asked them the effective management alternatives. How much will we reduce the risk of spread of a given species if we implement prevention in a block? We also elicited cost information on them. And then we can use tools like this. This is a Shiny app where we were eliciting dispersal functions for various species. And we had this little Shiny app with toggles so that they could tweak those parameter values and then see how that would translate to differences in spread from a specific location, from one infestation, and that spread homogenously around that infestation, but also spread along these anthropogenic pathways like roadways. So here, this is actually a simplified objective function, but what it's ultimately saying is that we want to allocate our resources such that we're minimizing damages weighted by the objectives, given some budget constraint. And we saw this using mixed integer linear programming. Output of this type of model can produce this cumulative treatment map, so darker areas where the model is suggesting that more resources should be allocated toward invasive species management. And we were also able to produce species-specific management maps that indicate, which recommended strategy to take within each given grid cell, where those strategies could be prevention actions, no direct action, search and destroy, or direct intervention. This work's also been integrated into a user interface tool directly within IMAP invasives. And so the managers are able to run the model and take the input and graphically work with it here. And they can take a look at the maps here, print them out for their crews, for example, and they can also produce really detailed reports on which species to treat and where. And this will also bring up information specifically about the species. So the parameters that were used in the model, such as what are the impacts of this species on agriculture or on native communities, et cetera. All right, with that, I'll go ahead and pass it over to Christine to bring us home with the last case study.
Thanks, Jen. So for this last case study, we're going to discuss a recent application of SDM to complete a review of Wisconsin DNR's CWD response plan. This was the second 5-year review of the department's response plan that was started late last year with myself and Jen as decision analysts. To answer this question, should the agency make any changes to the objectives or actions presented in the response plan? And if so, how should those change? Again, I'm just going to point out a few unique features about this process and gloss over some of the details. But one thing that makes this particular case interesting and unique is that it integrated structured decision making with a systems modeling approach. And this was through collaboration with the National Wildlife Health Center and their contractor, Ventana Systems. So to conduct the review, the DNR first established a committee, which if you advance one, Jen, I think there's an animation on this. First brought together a committee that included representatives from the agency as well as external stakeholders who are impacted by CWD or CWD response. And that committee provided input on the goal statement, objectives, and alternatives, those first steps of the structured decision-making cycle. And the effectiveness of the current response plan and the committee's proposed actions were evaluated using the systems modeling approach, so shown in dark blue. So that's where the systems modeling came in, was in that consequences step. So I'll dive in a little bit deeper into what the process looked like in the next slide. So starting at the beginning of the PROACT cycle, the committee first developed objectives. And this is an example of one of those objectives, which was to minimize impacts of CWD on wild deer and elk. Some of the sub-objectives are shown here in green, as well as how those were measured. The next step in the cycle, you can advance to the next slide, Jen, is that the committee was also engaged in this work of developing alternatives. And this case study, again, is a bit different from the ones that you've seen today, where we aren't dealing with just a finite set of alternatives. And some of the examples previously, for example, the elk case study that Jen shared, the alternatives considered were different bull elk quotas. There was this finite number of elk bull quotas that were considered. But in this case, we're actually interested in seeing how a set of actions, a portfolio of actions, could be used to achieve the set of the objectives that the committee laid out. So the committee developed these portfolio of actions that you can almost think of as alternative response plans. And these varied across 3 different dimensions: how the resources were allocated geographically, what deer, sex, and age classes were targeted for removal, and also who carries out the actions. And so by using this portfolio approach, we're able to assess overall strategies for CWD response as proposed by the committee, and then compare that to some of the current strategies in use. And then assessing these different strategies is where that systems modeling comes in the next slide. So the National Wildlife Health Center's modeling consultant Montana Systems developed this statistical model to dynamically map the complex relationships between biological and social processes for CWD. And as part of the structured decision-making process, the model was used to predict the consequences of each alternative response plan in the plan as currently implemented. And so I'm laying this out for you here again in one of those core tools of structured decision-making, a consequences table. So we have this portfolio of actions or alternative plans across the top of our consequences table. And if you go to the next slide, I think we should see that on the left-hand side there of the consequences table, we have the objectives that were identified by the committee. And then in the next slide, you'll see that that center part, which, sorry, the slides look like they're a little bit out of order here. So this is, there you go, thank you. The systems model is used to fill in the outcomes or consequences of those various portfolios, those alternative response plans across the top, to look at the outcomes of those on the objectives set out by the committee. And that slide that showed the systems model was just one part of the systems model that maps these complex relationships between those biological and social processes. And apologize to have you jumping around here, Jen, but if you, perfect. So how did we get then from this model to filling in that consequences table? So more specifically, we started with that text plan, that text description of the alternative plan. And then in collaboration with Montana Systems, we converted these text plan descriptions into model parameters. So for example, how much harvest might increase under an alternative plan, how much testing there would be, and so forth. Then the effects of the using the model were simulated to 2040, and these model outputs were used to populate a consequences table. So hopefully you're seeing that there are these opportunities to integrate structured decision-making with other scientific tools, such as systems modeling, and also to consider these broad strategies and make selections amongst broad strategies rather than just individual concrete finite alternatives. So this review is now at the final stages of the process, so more to come on this in the future. And I'm going to pass it back to Jen just for a couple of final thoughts on where we are interested in taking our structured decision-making work in the future.
Thanks, Christine. All right, so the big question, what's next? Well, Christine and I are really excited to start this new OAS service with potential applications of structured decision-making and decision analytics across agency decisions. And those can be operational or internal decisions, but also some of these like the ELK and CWD example, where we're working with really diverse stakeholder groups and tribes. There are also a lot of opportunities to better integrate social science methods to robustly integrate those stakeholder values like Christine talked about earlier. And also to evaluate process and outcomes of public engagement in SDM. And one area we're really interested in doing this is with changes in perceptions of fairness resulting from a structured approach like this that's more transparent and robust for decision-making. There are also a lot of tools like value information and sensitivity analyses, such as the one I showed in the Hunter R3 example, that can help better inform research needs. Not only where are the uncertainties within a system, but which of those uncertainties are the ones that are really hindering decision-making? And those provide areas where additional research would be the most valuable for decision makers. So I hope we've been able to highlight a diverse number of examples for you and tools and gotten you excited about how structured decision-making can be used in natural resource management. With that, I think we have some time and we can take any questions.
Thank you so much for that wonderful presentation. I think there's a lot of really good information there. So yeah, we do have time for questions. I don't see anything in the chat, but so feel free, those of you watching, to put something in the chat, or if you'd like to raise your hand, we can have you unmute and you're welcome to ask your question live. So we'll give it a minute to see if anybody has any questions they'd like to ask. I'm not seeing anything so far. Is there any point or anything that either of you would like to just kind of, really hit home for the group today?
I guess I'll just express that I'm really excited because I think this structured decision-making approach is going to lead to more effective co-production of science. And so I think that'll also provide a lot of opportunities to collaborate with, I'm sure, many of the individuals on this webinar today.
That's really awesome. Have either of you ever been in an effort where you feel like decision-making was improved because a tool like this was implemented, or maybe things got better over time because an agency started using structured decision-making?
Yeah, I think that's why we're here, is we definitely think this is a powerful tool. And, it doesn't mean that you're going to get a good outcome. Sometimes the outcomes are still dismal despite all the alternatives you have available to you. But at least what this gives us is, even in those worst case scenarios, is more information to check our expectations and acknowledge what we're able to achieve and what we're not. So I think that's a really powerful thing to be able to communicate, especially with the public.
Thank you. Yeah. We have a question in the chat. It says, what are some strategies or resources you can share to use this strategy in everyday decision-making?
Christine, you want to take this one?
Sure. Yeah, I was going to say that the consequences table that you saw a few times throughout the presentation is a really powerful tool for everyday decision making as a way to sort of think through a decision a little bit more critically. And it's something that you can scratch out on a piece of paper in 5 minutes. to think about, really what your objectives are, what you value, what you want to achieve in a decision, and what the different options are, and then thinking through which option might help you to best achieve your objectives. So just as a personal example, I've used this before in deciding where to go on vacation. For example, so what do you want out of your vacation? Where are the places that you can go, and what times of year, that sort of thing, and then be able to figure out where you should go and what time of year, depending on what you want to achieve, maximum relaxation, maximum fun, whatever it might be.
Great, thank you. We have someone asking if it's possible to share the PowerPoints or link to where they are housed. And so I will say that this session is being recorded, and it's my understanding that it will be posted to the YouTube page for Wisconsin chapter of the Wildlife Society. But in terms of sharing the PowerPoints or any resources, Christine or Jennifer, is there a good way someone could get in touch with you for that?
Yeah, I'll put my email in the chat, and I'd be happy to send you a copy of the PDF or something.
Great. Well, it looks like, yes, okay. We have confirmation that the presentation will be posted on YouTube soon. So thank you so much for this discussion today. It looks like we don't have any more questions, so I'm going to go ahead and wrap up the end of this webinar, but I really appreciate you both sharing this work today. And thanks to everybody for joining us. So everybody have a great rest of your week.